So I wanted to review some of your options that you can use for the Adopt a Molecule project online. These are 4 links that work in slightly different ways, but they can be used to either look up molecules that you don't know or your particular molecule as well. So let me first, I'm going to go to link 2 here, PHET molecular shapes. And once it loads, you can click on the model. And what you can do here is you kind of have a rotatable molecule. And you can click on a couple of different things. It will tell you linear shape. I would worry just more about that molecular geometry. And then what you can do is bring in different types of bonds. So, for example, the tetrahedral shape, remember, had 4 bonds, 4 bonding regions, and we get that kind of flat pyramid shape. It will also show you bond angles. Remember that one was 109.5. And then you can choose to show lone pairs when you have them. So let's see if I remove one of my bonds, then we get that trigonal planar shape. However, if I want to place a lone pair on there, remember the effect that the lone pair has is it forces it into the pyramid shape, trigonal pyramidal. And you can choose to show the lone pairs or not. And again, we kind of use the paddles in the activity to represent those lone pairs and explain the shape. So that's a good one just in kind of checking your work on molecular shapes. Another one from PHET actually lets you put in different atoms and different bonds. So I want to show you what that one looks like. Hopefully it won't take too long to load. That's not good. All right, well, that one loads. I'm going to bring up this link or explain this one. So to do this one, you want to just highlight the first part of the web link, and you want to go and paste that into a new tab. And then after the equal sign, you can type in a name of a compound or a formula. So I'm going to do H2O and hit enter. And it may take a second to load, but you get a ball and stick model for H2O. Okay, so that's kind of interesting. You can rotate it around. You can see the 3D shape of the molecule. Another thing you can do here is you can right click and get a bunch of different options. There it is. And one of the things you can do here is go to measurements and click on measurements. And I'm going to go to click for angle measurement. So one of the things for your information card is the angle. If I click and then click a second time at the center and click a third time, actually I double click at the center, single click, it will measure the bond angle for you. So from the notes, we had it as about 114.5. It's just rounding it to three digits, which is fine. So that might be helpful in finding your bond angle for your actual element. Let me see if the other one loaded. Still loading, so we've got an issue there. Let me load up the PubChem site. And here you can just, it's a search bar for different elements. So if I search water, for example, it brings up different entries. I'm looking for this one, right, H2O. And you'll have a bunch of information on the molecule. So for your fun fact, for example, you might be able to find something on the PubChem page. We've got a 2D structure, but what we're more interested in, right, is the 3D structure. So it's showing, again, another version of that ball and stick model for water. I want to talk about the other ways that we can represent this. So The way that we actually built our models with the straws and the pipe cleaners was more of a wireframe model, right? This kind of looks like our straws, and it doesn't show us the atoms themselves, but it does show you, in a way, the shape of the molecule. Ball and stick is a very common way. This is what your plastic models are going to look like somewhat. And I want to point out space filling. This looks kind of weird. This is actually a space filling model of water molecule. So really, in actuality, we want to think of molecules as kind of like overlapping atoms. Their electron clouds are overlapping. And this is a more accurate depiction of what a water molecule actually looks like. It takes into account the size of the oxygen atom compared to the hydrogen atom. And if I were to zoom in and look at the surface of a water molecule, it would actually look like that. All right. So that page can be useful. I want to just show you one other kind of big idea is if I search for a more complex molecule. One of my favorite molecules is caffeine. My coffee every day. And you can search for more complex molecules as well. And I want to show you how we can build out this idea of 3D shape with more complex molecules. So I want to find the 3D structure. Click on it here. And what I want to show you is even in a more complex molecule like caffeine, it's built from the shapes, the simpler shapes that we've been studying. So you notice this end here, this is actually a carbon and 3 hydrogen and a nitrogen. Notice it's a tetrahedral shape. And then that tetrahedral shape is linked to a trigonal planar shape. This is a nitrogen, carbon, carbon. And so the shapes that we studied are kind of simple molecules, but you can build them together to make more and more complex structures. Okay. So that's really how we can kind of extend this idea. Most molecules are built from the 6 or 7 molecular shapes that we looked at.